One other solution to the problem of whether to perform an upgrade or a clean installation is to create a dual boot environment, in which you retain the old operating system installation on one disk partition and create a clean installation of a Windows 7 on another partition. Dual booting enables a user to run either operating system at any time. The original operating system installation retains all of its existing applications and settings, but you must configure the new Windows 7 installation from scratch and install all of your applications. However, there are some disadvantages of dual booting, which include the following disadvantage. You must have a separate disk partition available to install Windows 7. Two operating systems require twice as much disk space as one. And finally, switching from one operating system to another to perform a specific task requires a computer to restart all over again, which can take several minutes. Dual booting is not commonly found in an enterprise computing environment, except as a makeshift compatibility solution. But some home users employ it to test new operating systems or maintain configurations to support different applications. To perform a dual boot installation, the bootloader of an operating system must support this feature. The bootloader of an operating system is no more than the first component loaded from the hard drive during the boot process, and is responsible for starting the operating system from a healthy stage. Usually, there are two purposes to create a dual booting installation. The first one is using unsupported application. This means that some older applications are not compatible with the newest version of Windows. Usually, the security in newest versions of Windows stop them from running properly and crash the computer or operating system. For avoiding this, the users or the network administrators can install a dual boot installation, in one partition they install the oldest version, and in the other partition they install the newest version. In this way, they can run the applications in different environments. The second reason is to keep configuration data separate. Sometimes network administrators want to have this dual boot installation for testing purposes, especially when they are gonna apply new service pack or updates to the operating system. Which this means is that you can have Windows 7, that is your main operating system, in one partition, and Windows 7, that is your testing operating system, in a second partition. In this testing environment, you can apply all the updates, upgrades, or service pack and see what is the reaction in your operating system before installing it in your main hard drive or partition. Windows 7 can perform a dual boot installation with almost any operating system. The main requirement is to install Windows 7 on a disk partition that is separate from other operating systems. The reason of this is mainly because of partition type compatibility. There are many types of partitions and formats: FAT32, FAT16, NTFS. Depending on the operating system that you're going to install, each one requires a different type of format. Windows XP, for example, needs FAT16 or 32, while Windows 7 needs NTFS. If you try to run these two in the same partition, they are gonna crash or collide, or it's gonna be impossible because they need to have their own format. The second reason is the application file compatibility. Installing multiple versions of Windows in the same partition can lead to problems with application files getting mixed up, especially when you have newer versions or older versions of the same application. For this, you can create a dual boot installation and have the application in different partitions with different settings and requirements. In this way, the applications can run without a problem and without crashing the operating system. Again, the only downside is that you need to restart all over again your computer every time that you need to do a different task in each of the operating system. When you configure a dual boot installation for Microsoft operating system, the rule is to install the operating system in the order of release, from older to newer. For example, to dual boot Windows XP and Windows 7, you will install Windows XP first. Windows 7 includes support for booting from a virtual disk file. In some cases, this can simplify dual booting by eliminating the requirement for separate partition and having to restart your computer every time that you need to use a new operating system. Most network administrators now use the virtualization software. Example of this could be the VMware Player or the Oracle VM Box. Virtualization software uses a main operating system as a host to run as many guest operating systems as you need. This depends on the license that you have with the virtualization software. Each guest operating system is a separate virtual machine that is also separate from the host operating system, so the settings and configuration are not going to interfere with your host operating system. The main advantage for virtualization over dual boot installation are the following: faster access to other operating systems. Instead of having to restart your computer every time that you need to use the other operating system, you can switch between them as fast as you switch from PowerPoint to Word. Multiple virtual machines at the same time. With dual boot installation, you can install only 2 operating system instances. With virtual machines, you can install more than 2 operating systems. Again, this depends on the kind of license that you have with your virtualization software. Simpler disk configuration. With dual boot installation, you need to create a different partition for each operating system. With the virtual machine, you don't need to create a different disk partition. Snapshots and undo disk. These let you choose whether to save or delete the changes you have made to a virtual machine. It's really similar to that last stage, the healthy known stage of your host operating system. After you installing a software update on a virtual machine, if you notice that it's unstable, you can revert to a snapshot made before the software was updated. Finally, we have the virtualized hardware. When you're using a new hardware, it's hard to find drivers for the old operating system. Or also, when you have older hardware, the drivers are not compatible with the new versions of the operating system. This is not a problem when you use virtualized software, because the virtual machine simulates older implements of hardware and their drivers.